And if I've done this right, nope, hang on, I may have to do it over here. Hold on. There we go.
Okay.
Also known as understanding what tables and computers tell you. So this is the fact that this is advanced one slide on me. I'm very excited because I'm doing it all with the little remote here. So we'll see how this continues to go. Oh, come on now. It may have just stopped. Ah, go that way. Go that way. Come on. There we go. If you remember nothing else tonight, remember this word, nitrogen. So I actually spent part of the afternoon redoing this stuff. And the whole idea here is all a dive table or a computer is telling you at all times is how much nitrogen you have in you, and really excess nitrogen. We really don't care about anything else. So I'm going to focus on that for the first part of this, but just we're dealing with nitrogen. So when we are breathing air, or even nitrox, whatever we're doing, it's made up of oxygen and nitrogen, okay? And
Can
also
I
I got to give a
interrupt
cap.
already? Can
Say
you
what?
let Gail in? Can you let Gail Chin in? She's trying to
Oh,
get
hang on.
she not on your list. She said she's waiting.
I do not see her in the waiting room. I've disabled the waiting room.
I'll have her text you maybe.
Okay, but I have disabled the waiting room. We got 20 people in, so she
I
should
got
be
out
able.
and back in because I lost internet connection.
Yeah, tell her, Michelle. Just tell her to try again.
Okay, I did. Thank you.
Okay,
Sorry to
okay,
interrupt.
that's okay. Um, anyhow, I'm a lot of this I'm simplifying to make it easier to understand because it's really easy to worry about when you go, well, wait a minute, it's not just oxygen and nitrogen. Isn't there some helium? Isn't there some argon? So some of the stuff is a gross oversimplification, but it's very easy to get into the weeds of all this and sort of
Are you leaving?
say what?
Never mind. Sorry. Can you mute me?
I don't know who that is, and I don't know where they want to move. So I'll assume it's not meant to be heard.
Mute,
Mute.
MUTE.
Oh, mute. Yeah. Who was that asking though?
Dave Shapiro.
Hi, Dave.
Hi.
Shia. Shia.
John, are you Diver Dave? Dave?
I'm Diver Dave here.
David
I'm
Shapiro.
Diver from Marina Del Rey.
Yeah, yeah. Hold on. Oh, there you go. I got you. I got
Thank
you.
you.
David is now muted. Um, all right. So anyhow, everything's fairly simplified. And has Gail Chin got in?
It
Gail
looks
is
like
in.
it.
Welcome, Gail. Um, so what we're breathing, whether it's air or nitrox, it's just oxygen and nitrogen. And basically, we don't care about the oxygen. Why don't we care about the oxygen? Anyone? Or no one?
It doesn't do the same as the nitrogen. Doesn't
Well,
react.
we're burning it up.
Right, burning it up. The
We burn
nitrogen.
up the oxygen, we turn CO2, we spit it out, we don't care.
Right,
Nitrogen, however, is an inert gas. And all that means is we take in the nitrogen, it rambles around inside. It's not going to really do anything, and then we're gonna get rid of it. So the problem though with nitrogen is, when we get into the physics and stuff, is while the nitrogen is inside us, we're absorbing it, and that can cause some problems. So the thing to know is your body can only handle so much nitrogen. All right, we do have limits with that, and when you get too much nitrogen in you, as hopefully you all know, that is basically the bends. So anytime we're talking about the bends, we're talking about an excess of nitrogen. Anytime we're talking about monitoring the nitrogen in our body, we're talking about avoiding getting the bends. Sort of as simple as that. But again, nitrogen is the key thing that we want to remember, that we want to focus on. So if you remember nothing else tonight, we want to focus on the nitrogen aspect of things. And one way I like to think of your body, our bodies, is it's like a glass, okay? And on the left side, you see a glass that's empty. That's the way we are at the start of the dive. We got no excess nitrogen in us. We've got nitrogen in us right now. I mean, the thing to remember in physics, without scaring you with the physics too quickly, is that everything wants to move to a state of equilibrium. So right now we've got a quote-unquote normal amount of nitrogen in us. When we dive, because we're going to absorb some nitrogen, we're going to start filling up with excess nitrogen. The picture on the right is supposed to be an overflowing glass, and it represents the bends, because basically when you absorb too much nitrogen and you exceed your capacity, it flows out, and the stuff that's flowing out is the bends. So the way it would look, and the concept that hopefully makes sense to you, is during dive number 1, you're essentially starting with an empty glass, okay? So no excess nitrogen. And as we dive, we're going to slowly fill up with the lovely yellow liquid. That is not a urine sample. That is supposed to be the nitrogen. We're going to slowly fill up with nitrogen. So you can see on the right side of that graphic, we're now right at our no decompression limit. So a full glass, a full U, is considered no decompression limit. So now what happens, we come back to the surface, we get back on the boat. If any of you, well, we'll do it as a test. Did anybody remember what SIT is, what it stands for? No?
Surface interval time.
What was it, Gail? Or whoever said that?
Surface interval time.
Bingo. Give yourself a prize. Absolutely. I sent you guys out Uncle Ken's handy dandy guide to dive tables today. If you didn't look at it, no big deal, but some of that stuff is in there. But yes, surface interval time. So during the surface interval time, what's going to happen? Now we start off-gassing. So that full glass that you see there starts to get emptier. However, it does not really fully empty, because we're only going to sit out an hour or so, or 2 hours. It is going to only partially empty. So even though, the other concept to get in mind, even though it's going to take you, let's say, an hour at whatever the depth is to fill yourself up, it is going to take you as much as 24 hours to get rid of all of the excess nitrogen that you just accumulated. So all we're doing the whole time we're looking at our dive computers, or we're looking at dive tables, is we're tracking the excess nitrogen in us. So in the top one, we're going to fill all the way up, come back to the surface, we're going to get rid of some of it, but not all of it. The amount that we have left in us,
Residual nitrogen.
when we go back for the next dive, is residual nitrogen. So here's dive number 2, but we do not start as an empty cup of water, cup of nitrogen. We start with what we ended with after the surface interval. Now we're going to try to fill ourselves up again. We do the dive, the nitrogen increases. We hit the no decompression limit again. So notice one difference between, and again, this is a gross oversimplification of it, but notice the difference between the top graphic and the bottom graphic. Top graphic took a fairly long time to get full up. Let's assume we're diving to the same depth because we're filling up at the same rate. The bottom graphic filled up more quickly because you didn't start at 0 excess. You started at whatever, 50% excess or something like that. So the thing, again, to remember is we are constantly filling up, emptying out, filling up, emptying out, filling up, emptying out. Do 2 dives a day, do 5 dives a day. That general thing holds true, but you always got to remember you're not fully emptying out. So in case you forgot, nitrogen again is our culprit. Oxygen doesn't really factor into this. The other key concept to understand, and it will explain a lot when you are diving and you say, well, I hit a no deco limit, I have to go up. Well, not necessarily. Is rate of absorption. And again, we're talking rate of absorption of the nitrogen. And that basically, again, very simplified, shallower is slower, deeper is faster. So the shallower you are, the slower your uptake of nitrogen is. Another way to look at that is, we'll look at this in a second, is you're going to get longer bottom times. The deeper you are, the faster the uptake, you're going to get shorter bottom times. The other way to think of that, especially when you're diving with a computer, you're diving your computer, you see you've got 2 minutes of no decompression time left. Let's say you're at 90 feet. What do you want to do? Do you need to go all the way to the surface? No. As you go up, let's say to 60 feet or 50 feet, a shallower depth, you will see that remaining no decompression time get longer, because now you've slowed down the on-gassing, you've actually started some off-gassing. It's a complex way it computes it, but the bottom line is you pick up a little bit extra time by effectively doing what we would call a multi-level dive. But the overall concept is shallower is slower, deeper is faster. So the other way to look at this, come on, advance. Whoops. There we go. The other way to look at this is, again, we go to our glass, and let's just say our glass is 100 units. We don't care what the unit really is, but it takes 100 units to fill up that glass. And let's say we're diving to a depth of 33 feet, which happens to be 2 atmospheres. Just for the hell of it, and I'm making these numbers up. At 33 feet, our rate is 2 units per minute. So that glass of 100 units will fill up at 2 units per minute. How long can we stay down?
50.
Yeah, you take 100 units divided by 2 units a minute. That glass is going to fill up in 50 minutes, okay? Again, starting from empty. Same glass, starting from empty. Different dive. We're going to go to 66 feet. At 66 feet, again, I'm making numbers up, it fills up at 4 units per minute. Same question, how long can we stay down at 66 feet? Well, you do the math. 4 units per minute divided into 100, 25 minutes. So we went a little deeper, but because we fill up faster, that thing's going to reach the top faster, we can stay shorter. And again, 100 units you want to do at 99 feet.
Yeah, honey.
And hello, honey, to you too. It's going to fill up at 8 units per minute. 100 divided by 8, I rounded down 12 minutes. That's how long you'd have at that. So we've got this 100 unit glass that at shallow depth fills up in 50 minutes, medium depth fills up at 25 minutes, deeper depth fills up in 12 minutes. And that's a good illustration of how tables do too. Again, the deeper you go, the less time you have. And the reason is because you're filling that glass up to its limit and you don't want to overfill it to where you're going to get the bends or decompression sickness. So that's just the overall general stuff. So far, so good. Is that making sense to everybody?
Yeah.
Okay. Now we do the scary part, and the big names, and we get into dive physics and fun stuff like that. These are the big four names.
Boyle's Law, Dalton's Law, Henry's Law, and
Bingo. Boyle, Dalton, Henry, and Haldane. Charles, I don't consider one of the big four, but we'll do the big four. We're going to talk about Charles a little bit. So Boyle's Law is basically, it's sort of the most important, law, physics law in diving. It's basically pressure volume relationships, okay? It explains why your ears hurt if you don't clear them when you go down, why your sinuses might hurt, all kinds of stuff. But the basic rule of Boyle's Law is that when pressure increases, volume decreases. Very simple, hopefully easy to understand concept. The opposite is true as well. If the pressure decreases, the volume increases. And it is inversely proportional. So by that I mean if you double the pressure, you have the volume. If you multiply the pressure by 4, the volume gets divided by 4. We got a lovely handy dandy little chart here as I take a sip of my Pepsi no sugar. So you got depth, it's in meters unfortunately, but depth going down the left, 10, 20, 30, 40. We're not going to go below 40 meters, aka 132 feet. That's the limit of recreational diving. Absolute pressure, 1 atmosphere at the surface, not 0. We don't live in a vacuum. 1 atmosphere at the surface, we increase 1 atmosphere in salt water every 10 meters or 33 feet. So 2, 3, 4, 5, as you can see there. Gauge pressure, we're not going to worry about. Gauge pressure.
This is depth in meters, correct?
Yeah, depth is in meters, correct. Because I didn't think to update the chart today. But gauge pressure, we're not going to worry about. The gauge pressure, if you remember, if I don't want to denigrate a training. One training agency teaches the atmospheric pressure as 15 psi. The actual number taught by another agency is 14.7 psi. So that if you looked at your gauge right now without it being hooked up to a tank, it's going to read 0. So that's your gauge pressure. But we are actually at 1 atmosphere pressure. Sometimes you'll be reading about gauge pressure, and my advice is we're going to sort of forget about gauge pressure because it doesn't matter. It doesn't matter. But if you look now at the air volume, so we have this is in cubic feet. We have 1 cubic foot of air at 1 atmosphere. We go down to 2 atmospheres. Now the pressure has made that volume half. We go down to 3 atmospheres, and it's a third. So again, the thing to remember is inversely proportional means if you take the pressure times the volume, it's always going to equal 1. So 2 times 1/2 is 1, 3 times 1/3 is 1, et cetera, et cetera. And basically what's happening here, as you can see from the air volume column, that as we go down, that air is getting crushed back up into our lungs or sinuses or ears or whatever it happens to be. If you the surface volume equivalent is not a great chart, but if you started with say what?
No, that's okay, honey.
Huh?
No.
No?
All right, hang on, got it. If you started with a cylinder that's 1 cubic foot, let it go to the surface. If you do it from 1 atmosphere, it stays at 1 atmosphere. If you do it from 2 atmospheres, it'll be twice the volume. If you do it from 3 atmospheres, it's 3 times. That column sort of explains embolism, which we're not going to really worry about right now. But it tells you why it's a bad idea to hold your breath while you ascend. But that's Boyle's law, pressure volume relationships. Any questions on Boyle's law, or we're okay with that one? Okay. The resounding silence, I think, means okay.
Oh,
Okay.
I have one.
Fire away, Glenn.
So this pertains to the body, not the tank, because the tank volume is not going to increase or decrease.
Well,
right?
It does.
yes. Here's the thing. Here's the way it really works out. Boyle's law applies when you are dealing with a rigid structure.
Okay.
So, for instance, and I'm going to get to your tank question, and it's a good one in a sort of a little roundabout way. So, if we're dealing with your lungs, and Glenn, can you mute your speaker because I'm getting an echo? If you're dealing with your lungs, I go down to 33 feet, let's say 2 atmospheres. My lungs are going to be half the volume. Okay. I take my tank down, and I've got, let's say, 80 cubic feet in the tank. The tank does not shrink down to 40 cubic feet of air. However, I can't breathe the air while it's inside the tank. So as soon as you start to bring the air through the regulator and outside the tank, then yes, Boyle's law does take over. And that's why, again, you use up your air faster as you go deeper. Okay? Any other Boyle's law questions? Okay. Dalton deals with partial pressure. And what Dalton basically says is the total pressure of a gas, 1 atmosphere, 2 atmospheres, however you want to do it, is the sum of all partial pressures. All right, so if you take each component of the gas, in our case we're just dealing with oxygen and nitrogen, the partial pressure of the oxygen plus the partial pressure of the nitrogen will equal the total pressure of the gas. And it will be in proportion to how much of each component is within that gas. So if you had a 50-50 mix, the partial pressure of each would be equal. Round numbers, what's the partial pressure of air, oxygen, nitrogen? Anybody who wants to be brave?
87.
Round numbers.
Oh.
You're a little high. I'll give you a hint. You're 7 high.
20, 21, or 20 and 80.
Yeah, 20, 80s. If you really go, it's, I'm trying to remember what the exact numbers are. Tom, you might know, but it's like 20.79 and 79.82, and then some other random gases. I have always used 20% oxygen, 80% nitrogen. It is not exactly correct, but it is a 4-to-1 ratio, which makes the math tremendously easier. So that's always the way I go. 20% O2, 80% nitrogen. Again, it's not exact, but it makes it a lot easier to understand. So here's what Dalton's law says. We take a vessel at 1 atmosphere, the surface, and it's full of a breath, we'll call it a breath of air. The blue is nitrogen, the yellow is oxygen. We go down to 33 feet. Boyle tells us that the volume is going to be cut in half. Well, what Dalton is saying is, yeah, the volume's cut in half, but all the various molecules did not go away. They just got crushed into a smaller area. So you've still got 80% nitrogen, 20% oxygen. We go down to 33 or 66 feet. Now we're at 3 atmospheres and 1/3 of a lungful or whatever it is. The ratio stays the same. You just got them packed into a smaller area. And now we go down 99 feet and everything's packed closer together, but the ratio still stays the same, 80% nitrogen, 20% oxygen. It also explains, as if you can get this as a concept, if that's your lung, let's say, and I'm down at 99 feet and everything's crushed down to 1/4 the volume. Again, the ratios are still the same. If I take a full breath of air, it's going to fill up that entire red outlined lung. So at 99 feet, it's the equivalent, because everything's packed so tight together, of taking 4 breaths of air. And again, that's why you're using up your air more quickly at depth, because through no fault of your own, you're effectively breathing more and more of the air with every normal breath you take. So if we use that 80-20 ratio and look at everything, 0 feet, surface, 1 atmosphere, the nitrogen is 80% of that. The actual pressure is 0.8 atmospheres. Oxygen is 20%. Whoops, hang on, I lost my computer.
Where did it go?
I think what it did is it got bored and it went to sleep. I'll have to be more entertaining. 33 feet, 2 atmospheres. 80% of the pressure comes from the nitrogen, 20% from the oxygen. So 80% of 2, 1.6 atmospheres. 20% of 2, 0.4. As we keep going down, hang on, I've lost. We keep going down. I'm going to have to do this by hand, I think. 99 feet, and even down to 132. So what's happening here is, according to Dalton, the partial pressure of each gas is increasing, as you can see, but the ratio still stays the same. The ratio never changes. Now, we don't care about the oxygen. because we're burning up the oxygen, like we said earlier, basically taking it in CO2, spitting it out, not going to worry about it. The nitrogen, though, you'll notice we're getting an increase of the pressure, partial pressure. Oh, and I got my 5 atmospheres is wrong. That should have been 4.0. I don't know how that got to be 0.8. The nitrogen is going to be a problem because we've got more and more of it. And this takes us into, it's not working now. This takes us into Henry. And Henry deals with gas solubility. And what Henry says is that the amount of gas that's going to dissolve into a liquid is directly proportional to the partial pressure of the gas. And put in more vernacular, the higher your pressure of nitrogen is, the more nitrogen is going to dissolve into your tissues, your bone, your blood. It goes into a lot of different places. So when we raise the partial pressure of the gas, as we do when we dive down underwater to any depth, but as we go deeper and deeper, again, the nitrogen becomes the factor that's in play here. More of it's going to dissolve. You're going to absorb more into, like I said, the blood and tissues. Different rates. The blood can saturate pretty quickly, desaturate pretty quickly. Tissue's a little slower. Bone a little slower. We don't really know exactly, what is working there, what's not. So the thing to remember, I got to move one thing over here. The thing to remember with Charles's law is, where did I go? Temperature is going to affect. Oh, I'm sorry. Charles is temperature and pressure. Charles, the guy is sort of left out. Basically, as the temperature goes up, the pressure goes up. Temperature goes down, pressure goes down. It's a factor when we're filling tanks. You fill a tank and it gets hot, and maybe you got 3,200 or something like that. As the tank cools down, that pressure inside the tank drops. For our discussions, it's not really that significant. It's not a factor when we're talking about the bends and stuff like that. So we go back to Henry. And again, you raise the partial pressure of the gas. Nitrogen's what we're looking at. More of it dissolves in the blood and tissues. Why is any of this important? Well, it gets to be important because this is explaining how we get excess nitrogen inside us. And now we get to this guy, John Scott Haldane. And Haldane's a key factor in a lot of stuff that we know about. I'm having to do this with a mouse and it's bouncing around on me. Haldane studied problems with bridge workers in mainly around the New York area. 1907. So the thing that's amazing to me is here we are in 2025, and a lot of the stuff that we know about diving and why we get bent or don't get bent comes from a guy who did his research, knew nothing about diving, and did the research 118 years ago. But he looked at all the bridge workers, especially around New York. And the bridge workers were known as caissons. And they were so named because they built a watertight caisson to work on the various bridge abutments and stuff like that. And what they would do would be they would pressurize these caisson containers. Pressurized air, these guys would go down, usually to a depth of around 60 feet or so, be down a good part of the day. They would then walk back up like an incline thing. And they had some idea about what was going on because they knew sometimes when guys came back to the surface, they would be bent over in pain. And so the bends was originally called Caisson's disease because it affected caissons, as in the workers. And a lot of them became crippled. And so Haldane was brought in to try to figure out what was going on there. As a total side note, apropos of nothing other than it's the Brooklyn Bridge, the David McCulloch book, The Great Bridge, which is all about the building of the Brooklyn Bridge, has a phenomenal chapter about this and about the caisson workers getting bent and what they knew and what they tried to find out about in the day. So if you've never read it, I recommend it. It's very, very interesting. Back to Haldane. Haldane figured out, hang on one second. Susie, I'm in the middle of a lecture. I'm calling you back in an hour or so. Haldane is the one that figured out nitrogen was the culprit with everything. And what he said, again, gross simplification. Nitrogen can double in your body. Again, excess nitrogen. And you can come back to surface pressure with the nitrogen in your body, double what it normally would be. Not a problem. But if you allow the nitrogen to more than double, now we got a problem. That's where we get Caisson's disease. You can call it bubble trouble. We call it the bends. More formally, it's known as decompression illness. As the saying goes, a rose by any other name. All right, these all mean the same thing. And it's something you don't want to do. So the factors that will affect all of this are going to be how deep are you going? Because as we saw just a few minutes ago, deeper is faster uptake, and you're going to hit that doubling limit more quickly. Again, shallower, slower, deeper, faster. Time, how long are you down for? So if I'm down at 90 feet for 20 minutes, I absorb a lot more nitrogen than if I'm at 40 feet for that same 20 minutes. So depth and time factor in here. The cool thing about all of this is all measurable. We can create mathematical models. We can predict fairly accurately how this all is going to play out. There are other factors, though, that come into play that you need to figure in. Age. Look around here. We ain't young pups anymore. Hydration's a big thing. A lot of times on trips, you'll hear us talking about hydrate, hydrate, hydrate. Dehydration factors in a lot of times to Ben's cases. Fatigue. You tend to absorb more nitrogen when you're tired. But again, the thing to remember is anytime we're using dive tables, anytime we're using dive computers, all we're tracking is the amount of excess nitrogen that we are absorbing and then somehow factoring in these other little factors. And again, the thing to remember is the big word in physics is equilibrium. Everything wants to go from high concentration to low concentration to where they get themselves equal. So if you are diving down to 60 feet, 90 feet, whatever it is, you have very little excess nitrogen in your body. But the air you're breathing has a much higher pressure of nitrogen. So you absorb it. It's going to go from the high pressure of the air you're breathing into your body. When you come back up, now you've got a higher pressure of nitrogen inside you. And you come back to surface pressure where the pressure is lower, 1 atmosphere. Now this explains why you will be outgassing. Your body wants to get rid of the excess, get to equilibrium, get it to a normal level, and so you're going to be blowing off some of the nitrogen. And again, if you don't do this right, the nitrogen comes out of solution too quickly in your body, forms bubbles, you can't exhale it all, the bubbles go bad places, and that's where we get the bends.
Ken,
Yes.
on those factors, when I was training with a Navy SEAL, he said for every extra pound of fat, you have an extra mile of capillary beds.
Okay. Could well be.
Gives you a lot more places to be storing that extra nitrogen.
Yeah. Yeah. And again, we know, let's face it, we're not all in the same shape we were 20 years ago. So you've got more fat than you used to. You're probably not in the same condition as you used to be. Diving in cold water versus warm water, all these things matter. Yeah. Do they change things radically? In other words, let's say the limit at a given depth is 25 minutes. Does it suddenly make it 15 minutes? Probably not. But does it make it 24 minutes and 32 seconds? And then for someone else, it makes it 23 minutes and 50 seconds? Well, you don't know. And even from that, you will be different day to day. I was more tired today. I was less dehydrated, or whatever the case might be. There will be little variations. So, unfortunately, the bends is a pass-fail test. I've said before, it's like pregnant. You either is or you isn't. And it's the same thing with the bends. You either is or you isn't. So, and we'll talk about this a little later on, but whatever safety factors you can build in, have at it. Like, as I've gotten older, I do 5-minute safety stops now, not 3 minutes. And if I do a 7-minute safety stop, that's all, fine and good. I don't push decompression limits. Remind me at the end, I'll talk about setting your computer to 28% instead of 32, and I'll tell you why. I meant to put that in the slide, and I totally forgot. Those kinds of things. So yeah, that all absolutely factors in. The analogy I have with, again, trying to get you to understand residual nitrogen is the credit card analogy. When I first started doing this, by the way, I had a $1,000 credit limit, which in 1980 when I started teaching, oh yeah, that was really good. So let's say you have a credit card that's got a $10,000 limit on it, and you go out this month and you spend all $10,000. You get the bill, and you decide, I'm going to pay back, $6,000. How much can you go out and spend the next month? Anybody?
$6,000.
One more time?
$6,000.
You can spend $6,000. So you've got a $4,000 residual on this. You can't go out and spend $10,000 again, even though that's the limit. So you have to factor in what you did not pay back. And the difference with diving is our limit changes every single dive. Oh, I've got a 25-minute limit here, but I've got 0 residual, so I've got all 25 minutes. But now I go do dive 2 and I've got 30 minutes of residual. Oh, but I got 60 minutes available bottom time. Well, now I have to subtract the 30 from the 60 because I'm starting at 30. It's like your body clock starts at 30 and see what you got. So you got to watch those limits. What tables and computers are doing is all they're doing is tracking the excess nitrogen in your body. How much did you start with? First dive, it's going to be 0 excess. How much did you add? What's your current total? What are you paying back? What are you getting rid of while you're on the surface? That's the equivalent of making your monthly payment. So what kind of a what kind of a limit do you have now that you're going to do a second dive to a different depth? That's all that these tables are doing. All right, Navy tables on the left, PADI tables in the middle, NAUI tables on the right. I'm just curious, and you can do it by. I'm gonna. Whoops! I got to move this thing. I'm gonna move something around for a second for me. I'm just curious. Show of hands. Does anybody still dive tables?
No.
Okay, Dave. And would anyone know? Here's a trick question. Would anyone know if your computer went down how to convert your dives to tables?
Yes.
Okay.
Have
But
a
I'll tell
second
you why it's a
computer.
trick question. Because chances are, if you've done 2 dives, you're off the table. You're beyond table limits. So anyhow, but it's always a good idea to have them with you. All right. So I'm not really going to run through a lot of tables, but I got to move this back over. There we go. But the thing to understand is these all have the same concept behind them, but it's like they speak 3 different languages. And the reason I mention it that way is the numbers from the Navy table don't necessarily translate to the PADI table, don't necessarily translate to the NAUI table, even though they're all sort of saying the same thing, giving you the same information. But here's the things to know about any dive table. And it was so funny. The first time I met Carl, you guys all know who Carl Huggins is. Carl's our director of the Catalina Chamber.
Yeah.
The first time I met Carl Huggins in 1992, I think it was, he was lecturing at what's called UHMS, Undersea Hyperbaric Medical Society. And it was out here, regional conference, and they were doing a thing for all the local instructors. And, in 92, that was the early days of computers. So a lot of us were still doing tables. Patty had just introduced the wheel. We just thought we were all high tech back then. But Carl hands us all tables that are written in German. And we're going, what the fuck is this? And his point was, it doesn't matter what the language is. Math is a universal language, and all tables are constructed the same way, and computers are constructed the same way as well. So here's what's happening. Table 1 is going to be the dive. We're dealing with depth and time. All right. Table number 2 is going to deal with the surface interval, the time between dives, aka the off-gassing. To use the credit card analogy, it's how much we're gonna pay back. And table 3 is right before you go in for the next dive. It's going to tell you what you have left over, what your new limit is, and so how much you can actually do the dive. So the thing to understand is the outgassing limits on the various tables, and this applies to the computers as well. And again, remember, everything is a mathematical model. The outgassing limits differ. The ingassing, I should say rates, not limits, but the ingassing rates are different too. The Navy uses 12 hours. So you do a dive and wait at least 12 hours. After 12 hours, they consider you back to normal, okay? Patty, and I'll explain why in a second, only uses 6 hours. You do a dive at 10 in the morning, at 4 in the afternoon, or 4:01, you're clear of excess nitrogen. And again, remember, we care about this because it's the excess nitrogen that's going to get us in trouble when we go dive if we exceed that doubling limit. NAUI says 24 hours. You do a dive at 10 in the morning, you're not clear until 10:01 the next morning. Doesn't mean you can't do another dive, just means you have to factor all that in. A little bit of history about this. So the Navy came up with their tables, and the way they would test them is they would take their young, fit Navy divers. They would say, you, Turney, 60 feet, 55 minutes. Tom would go do that dive and come back up. How you feel? I feel fine, sir. All right. You, Robin, 60-60. Come back up. How you feel? I feel fine, sir. Fine. You, Glenn, 60-65. How you feel? My shoulder's hurting. Okay, throw you in the chamber. That's how they validated the tables. And supposedly, I was not a Navy diver. I was not a Navy guy. But there were also places on the tables where they said, well, this is what the math says, but this one doesn't work. And they like put a little X by it. But that's how they tested it. And also with the Navy, most of the time they're doing single dives and there's a chamber nearby. We're not doing that. Doesn't mean there's anything wrong with the Navy tables. Just means that's something to consider. Patty did some research, hired 2 guys, Lewis and Powell, in the mid-'80s, I want to say it was. And Patty said, we're not all Navy divers. And we don't think some of the things we deal with in terms of dealing with Navy divers really apply to recreational divers. So they asked Lewis and Powell to do research and do actual testing and come up with new tables. And they did. NAUI at the same time, because there's a competitive nature to this, wanted to come up with tables. But NAUI doesn't have any money, never has. And so this is how NAUI came up with their 24-hour thing. They said, well, if 12 hours is good, 24 hours is better, so we'll just leave it at that. But what was driving all of this, and this is where I'll explain the 12, and the 6, and the 24, is the idea of a half time. And a half time, I don't know how well you can see me right now, but my glass is about My glass of Pepsi no sugar is about half full. Halftime concept is how long does it take to get halfway to something? In our case, a no decompression limit. How long does it take to get 50% of the way there? All right? And there's a rule in decompression that basically says 6 half times equals saturation. So the first half time, you get to 50% of the way there. The second half time, you've only got 50% to go. So half of that is 25%. That puts you 75% of the way there. The third half time is 12.5%. The fourth half time, 6.25. It's that old joke of, if you're standing on a football field and you can only move half the distance each time, you never cross the goal line because it just gets smaller and smaller. So after 6 half times, you're at 98.4575%. That's considered saturation. The opposite is true as well. That you desaturate 6 half times is full desaturation. So the Navy was using a table, mathematical model, that had based on 6 tissue compartments of varying half times. And the slowest one was 120 minutes. And so using that saturation math, 120 minutes is 2 hours. 2 hours times 6, 12 hours. That's why the Navy says you desaturate in 12 hours. Patty, with Lewis and Powell, took a very different approach. They looked at all that stuff. They said, we just don't think the 120-minute tissue is a factor with recreational diving. So to get an idea, the 120-minute tissue, it takes 2 hours to saturate. And so they said recreational divers don't dive at depths or for such a long period of time, because Navy divers are generally working divers. If it takes you 4 hours to weld something, you're down for 4 hours. We're not going to be doing that. So what Lewis and Powell said, and it's a really important concept, and it really changes a lot of stuff. They said, we don't think the 120-minute tissue applies. Instead, we think the 60-minute tissue is what the longest tissue is. And when you go back to that idea of 6 half times, it means in 1 hour, 60 minutes, 1 hour times 6 half times, that for Patty, you outgas in 6 hours. So the thing to understand there too, and we'll get into a little Minutia times here in just a minute. The thing to understand there too is that if I do a dive and I'm looking at Nowie tables versus the dive Navy tables or dive Patty tables, the in-gassing rates may be different. But when I come back to the surface, my outgassing rate is absolutely going to be the same. The difference is going to be those 3 tables will each say I start with a different amount of nitrogen in me, because they're all based on different assumptions, mathematical models, of how you're absorbing the nitrogen. So again, now he said with no money, we're going to just double the Navy thing. They backed off on some of the no decompression limits, and that's their table. So again, the caveats here, and these caveats apply to computers as well. When you are diving with a computer, do not take it as gospel. For various reasons that we'll get into in a minute. It's probably running you, I won't say they're less, I don't want to say less safe, but there are so many factors in actual tables. I went to 65 feet, I got it counted as 70. I was down for 22 minutes, I got it counted as 25. There's so many different things in there. I got it counted as a square profile so that I was diving as if I was at 70 feet. I spent half the dive at 40 feet. There's so many things like that in a dive table, that dive tables, if they're followed, are probably less likely to get you bent than anything else. But they're all mathematical models. Each mathematical model is based on what are called compartments. I cannot do the math with this stuff. But the Navy table had 6 compartments. Some computers had 12 compartments. Others have 9. You could design a mathematical model with 20 or 30 compartments. You could design one with 1 or 2. Are they more accurate or less accurate? Depends on how you're doing stuff. So the thing to remember is they're all mathematical models. And remember too, your body physiology is going to play a part as well. How in shape are you? How tired are you today? How dehydrated, whatever. The good news is that even though the testing was done on the Navy tables, as I mentioned, on young, fit people, from a practical standpoint now, we've been using dive computers for 35 years or thereabouts, 40 years. If there were flaws in the dive profiles, half of you people on this call would have been bent at some point or another. So the point is that they must be pretty good, and or we don't really push the limits that much. But for the most part, they're all pretty accurate. I am told that a lot of times when people come to chambers, the words they hear most often are thinking about. And when we say, how deep were you and how long were you down? The answer is, well, I think I was at 60 feet for about 45 minutes. That's the other good thing about a computer. It is a witness to everything, and it doesn't lie, and it doesn't fudge the numbers. However, if you're concerned about getting bent, there are 2 ways to guarantee you will never get bent. Number 1, don't dive. Number 2, if you're going to dive, don't surface. We don't get bent until we surface, but that one's probably not too practical. So some secrets when you're thinking about the dive tables. Again, the magic number is 3. You always need to know 3 things. I need to know depth and time to get my surface group. Anytime you get 2 of the 3, you can figure out the third. It's especially useful when you're planning out multiple dives, because you can work forwards or you can work backwards. Let me take a quick look with you at some dive tables. So looking at what you see here on the Navy tables, I don't know how many remember the old paper Navy tables, but what you were seeing, I got copies here. What you're seeing there are not table 1, but you're seeing table 2 and table 3. Patty table in the middle. You're seeing table 1 and table 2. Table 3 is on the back. The NAUI table, you're seeing everything. Table 1, upper right. Table 2, lower right. Table 3, lower left. You can also see, comparing the Patty and the NAUI tables, how many more numbers, especially in that table 2, that there are. Patty really breaks it down much more finely than the NAUI tables do. The other thing you'll notice on the Patty tables in the middle is the letter group goes from A to Z. On the NAUI table, it goes from A to L. On the Navy table on the left, it goes from A to N and then O and Z. The letters are not equivalent. So a NAUI E is not equal to a Patty E. It may be close to a Navy E, but the letters are not the equivalent. Whoops, I hit the wrong button there. Hang on. There we go. So here's a couple of dive profiles. I'm not going to run the profile, but I'm just going to give you all the various numbers. 60-30, NAUI's an F, Patty's an L. And here 50-40, F and M. 80-35, Patty won't let you do that. Their limit is 30. 51-40, when these are on tables, H and Q. 49-51, H and Q. The point here is each of these under the NAUI and the letter under Patty represents the exact same amount of nitrogen. You don't absorb more or less nitrogen, when you're diving NAUI tables and do Patty. It's just the letter group is different, and where you go afterwards is going to be a little bit different. To give you some idea, these are table stuff I ran. So the way to read this, we do a 70-40 dive, surface interval of 1 hour and 42 minutes. The next dive is going to be 50 feet. My residual nitrogen is 38, and I have 42 minutes of time available because the total time at 50 feet on the NAUI table is 80 minutes. So the thing to look at is that yellow number, 4209, 14, 57, 31. So each dive is on a line by itself. How does the NAUI table compare to the PADI table? Remember, the NAUI tables are based on, and this is going to show you the differences between what assumption, what mathematical model you try to use. The NAUI table is based on the Navy, which puts 120 minutes as the slowest tissue group. The PADI table is based on Lewis and Powell, which is going to give you 1 hour. So you're going to have a little bit different ingassing and get different outgassing credit. So look at the differences. On the PADI table, you can do 53 minutes where NAUI would only let you do 42. On the second line, it's a deco dive, so it's a don't do dive. NAUI would have let you do 9. 39 versus 14, 100 versus 57, 44 versus 81. So that if you were going on vacation and you would choose one of the two tables, and if I told you each table is equally safe, you're probably going to choose the PADI table because you're going to go, I want to do more dives. So what I want to tell you is you're making that same decision when you're choosing computers. Different computers have different models. Some are more liberal, shallow. Some are more conservative, deep, whatever it might be. And again, these are just trade-offs you're gonna be making and looking at stuff. So some things with table facts. Tables, as I mentioned, it's a square profile. Whatever your deepest part of the dive is, that's how deep the table says you were for the entire dive. Computers don't do that. You're always going to round up on tables. So a 72-foot dive gets logged as 80. A 29-minute dive gets logged as 30, stuff like that. Computers don't do that. Those, even though just two things, build in huge safety margins on tables. But tables give you less dive time. I don't want new software from Apple. Hang on, that's on, I'm trying to tell which computer that's on. There we go. Tables are going to give you less time. We want more time. You know, if I'm flying 20 hours to go to Palau or something, I'd like more time, not less time. And with the table thing, years ago I had a student who was a computer nerd. This is probably back in the early 80s. And we're going through the tables. He goes, but this isn't right. And he says, you know, I wasn't really at 70 feet for the whole dive. I was up at 50 and it's penalizing me too much. And I said to him, well, this is the way we use these things. And if you want to like invent some computer that will account for that, you go right ahead. And I'm convinced to this day that he probably took my words and invented some computer and made a fortune at it. And I should get a royalty or something, but that's just the way it goes.
His name is Joe Sunto.
Yeah, no kidding. So we get into dive computers, and what we find out with dive computers is they can deal with us on a multi-level profile. We're at 70 feet, we go up to 50 feet, we go to 40 feet, we bounce down to 60, whatever it is. The computer's going to say, where are you? And decide what's going on. They really compute in 3D. They're on-gassing in some tissues, they're off-gassing in others, etc., etc. Because of all that, not that they're dangerous, but they probably have less safety margins than you might think they do. They definitely give you more dive time. But we also know in just general terms, the more you dive, the more your chances of getting bent are. The longer we stay underwater, the more chances we have of possibly getting bent. The first dive computer was called the Edge. Yeah. And the reason it was called the Edge was because it really took you to the edge of safety. There's a picture of the Edge. Tom Turney's not allowed to answer this. Does anyone else know who designed the algorithm for the Edge computer? All right, Tom, you can weigh in.
Was it Carl?
Yeah, Carl Huggins. So I always told Carl, if I was ever diving on an Edge or a computer he designed and I came to the chamber, I expected a free treatment.
I knew that.
But
I
anyhow,
knew
this
that.
was the edge, and it was also known as the brick. If you look, this is really two pictures. But you look at that picture on the left, and this thing, I think it weighed, I don't know, 3-4 pounds easily, and was about 12 or 14 inches long and stuff like that, and had this little window. But it was really interesting because you look at the middle, the bigger picture, all those dark pixels, you basically were diving, so the pixels never exceeded that curved line. And it was really a very revolutionary thing. Carl actually did the algorithm, I think, when he was a graduate student at the University of Michigan. This isn't really a computer, but this is one of the first things that sort of passed as a computer. Probably read the right one better, automatic decompression meter. This was also known as the Benzomatic, because a lot of divers showed up at chamber with one of these in their hands, and they were quite bent, even though this thing said it wasn't. It had a piece of paraffin inside that supposedly reacted while you were underwater the same way your body did, and that little needle would go up and tell you either how much time you had left or how much time you needed to decompress when you got into the black. And not exactly the most accurate thing, but an interesting thing. This was the first really popular dive computer, made by the same people that made the Edge. It was known as the Skinny Dipper. I still see some of them around nowadays.
I still have a working one with the original battery.
Yeah, well, there you go. Well, I hope not the original battery, but yeah.
Original battery.
Ken,
Yes.
I have one.
Oh, good.
Can you see? Can you
Oh,
see
wait a
the
minute.
picture?
No, you're covered up. Hold on. Wait a minute. I have to move my participant list. Where is it? Oh, there we go.
Yeah, I have
Yeah,
one.
Marilyn's used it. Now, the downside of this, there's a number of downsides, but one of the downsides is if you're diving nitrox, these are only good for air. So if you're diving nitrox, they're not good as a backup computer, but they're really, really reliable. There was a problem with the Skinny Dipper, though. Same problem with the Edge. You could turn them off. So divers would be going and say, oh, that's not giving me enough bottom time. Turn it off. Turn it back on. Oh, yeah, that's a lot better. Unclear on the concept.
What year were these manufactured?
Skinny Dipper was probably early 90s, I want to say.
Hey, Ken.
Yeah.
I just looked at my logbook. I dove an Orca Edge, and it was the blue, so it's actually earlier than the one June 1984.
Wow. Yeah. That sounds about right. Because, the first thing, those first computers were, everyone was very skeptical about. So the Skinny Dipper could have been 85, 86, 87, somewhere in there. But yeah, divers turn off. The joke story that you hear, almost every dive master, well, let's put it this way, every dive master my age will probably tell, was, and I heard this the first time down in Sea of Cortez, on a boat, a couple of days into a multi-day live-board trip, week-long trip. And everybody's in the galley having lunch. And the dive master's walking around the deck. He sees a line tied to the side of the boat going down in the water. And he pulls up the line, and it's someone's Edge dive computer on there. And he walks into the galley. He says, "Whose is this?" And some guy raises his hand and says, "Well, why is it underwater?" He said, "Oh, my computer needs to decompress." So sort of unclear on the concept. This was another early computer from Oceanic, actually based on dive tables. It actually gave you, this is actually one of my old ones. It gave you a letter number at the end, and it was interesting. It computed, I think what it was, it sort of computed multi-level, but based on tables, and then it outgassed based on tables as well. The thing I liked was it gave you bottom time in hours, minutes, and seconds. So that was always fun. But nowadays you've got just a ton of computers to choose from. And really, when you get down to it, your decision is sort of, do you want it on your wrist or do you want some sort of a console? I mean, what's ironic, I started diving in 1978. And at that time, everything was mounted on your wrist or on your arm. And we didn't have computers, so you had a depth gauge and stuff like that. And the high-tech thing then was called the Peniform console, that it was a plastic console. You could put all the things. The bottom one was your pressure gauge. So it's sort of attached around your pressure gauge, and you could mount a compass, you could mount a depth gauge and stuff like that. And over the years, we evolved into console computers. And then probably early 2000s, maybe, especially with the advent of tech diving, we started going back, stuff on your arm, stuff on your wrist. Personally, I don't like it. That's just me. But I just find it interesting that, you know, it's like what was old is new again. So there's a thing going back. But the computers nowadays give you all kinds of information, multiple screens. You can see the ones here, like on the right. You got 92 feet. You got 14 minutes and 48 seconds left. They want you to do a 2-minute safety stop. They're breathing air. Gas time remaining is the middle number, 21 minutes, and your current tank pressure is 2250. Similar information on the middle, the Oceanic Pro Plus X. You're at 125 feet. I don't know how the hell you got 16 minutes of no decompression time, but they say you do, let alone 2340 air. Gas time remaining 12. So you get a lot of information. And on some computers, if any of you are deciding on a new computer or something like that, some of them just give you too much information, or the numbers get to be too small. Again, as we get older, you know, there was a computer we used to sell when we had Reef Seekers open as a brick and mortar store. It was called the Eon, and I had this one guy who loved it, but the numbers were real tiny, and he said, I can't read the damn thing, so he had to buy something else. For what it's worth, this is the computer I dive with, the Pro Plus 4. I do like it because it's got big numbers. It gives me the information I need. I do not have a compass on it. I dive with a little, believe it or not, a Boy Scout compass in my pocket. But the main screen, like sort of what you see on the right, 54 feet, what's your gas time remaining. One thing I like about this, it shows me gas time remaining and no decompression remaining. Shows me both those numbers at the same time. A lot of computers will only show you one or the other of those. It will show you the lesser of the two. The logic behind it, which I agree with, is if I've only got 14 minutes of no deco time, why do you need to know you got 28 minutes or 26 minutes of air time? It's irrelevant. You're going to run out of no deco time before you run out of air. If the air time is shorter than the no deco time, you may have 14 minutes of no deco, but you only got 10 minutes of air. That's the number it'll show you. But again, the number you want to watch is on this one, the 1305. Down there at the bottom. For what it's worth, these are, I don't know if you can really tell from the picture, these are both quick disconnect computers. Personally, I am not a fan of the quick disconnect. Couple of reasons. One, it's one more failure point. You're continually plugging it in, plugging it out to your hose. So you may, have an O-ring go or something like that. The other more practical thing is my friend Jay Wilson, who we were on The Man Theory a number of years ago, like 1996 or 2000 or somewhere in the 2000-ish. And he had a detachable one, and after every dive, he would, on dives in the Maldives, you dive off a separate dive boat called the Dhoni. So there's the mothership, then there's the Dhoni. All the dive gear stays on the Dhoni. So we get off the Dhoni, he'd take his computer with him, go upstairs, go back on the boat, log it. And one or two times at least, we'd have the Dhoni pulling away and you hear him go, son of a bitch. And I said, you left your computer back on the main boat, didn't you? And he said, yes, I did. So for me, I'm just personally not a fan of quick disconnect, but again, whatever floats your boat. Same problem can run with anything on your wrist. If you're taking it on and off the boat, it is possible for you to leave it behind. But some decisions you want to make, either if you're diving computer now or not, air integrated or not. Most of the computers nowadays are air integrated. The ones that are wrist mounted, and you'll have a little transmitter, all they're doing is transmitting air pressure to your wrist. So if the air pressure part should go, you've still got it as a computer, but you will not know how much air you have. Anything that's mounted on a hose, again, the hose is transmitting the air pressure, but I think you're less likely to lose that information. Although the rule of thumb would be, my thing is I should be able to cover up your computer or gauge, ask you how much air you have, and you should know within a couple hundred PSI. If you find you're diving and more than 500 PSI has gone by before you last checked, my opinion, you're not looking at your gauge often enough. So assuming you're diving with a 3,000 PSI aluminum tank, you should be looking at 2,500, 2,000, 15, 1,500, stuff like that. Anytime you're under 1,000, you definitely want to be keeping an eye on things. Anyhow, we could talk about this for a couple of hours. Conservative or liberal? Some computers are conservative at depth, liberal shallow. Other computers are very liberal at depth, but conservative shallow. There's a theory of decompression that when people get an unexpected bends hit, it probably comes from slower tissues because they're slower to on gas, they're slower to off gas. The fast tissues, zoom, zoom, they fill up, they empty out. So that's why some computers will give you less time shallow than others. But again, the thing to know with any computer, and the general rule of thumb, again, we go back to slower, shallower, slower, faster at depth in terms of uptake. You find yourself running down on your computer, and a lot of people will sort of ride the no decompression limit this way. Let's say I'm diving to 90 feet. I run the computer down to 1 minute, 2 minutes, whatever left. Now I go up to 70 feet. Maybe now I got 10 minutes. So I run it down again to 1 or 2 minutes. Oh, now I go up to 50 feet. I keep going. Anytime I'm going to go up, my computer's going to give me more bottom time available. So some people will ride that up. Now, when you're doing that, you're really, riding out all the safety margins that might be built in there. So if that's a risk you want to take for some extra bottom time, so be it. But again, in terms of what's liberal, what's conservative, it's hard to say anything is exactly this or that because there are so many variations that you can go. So it's really important to understand the algorithm model. Steve Herbert sent me a note today. We're talking about the idea of a backup computer. So if you have a backup computer, you want it to be ideally the exact same computer as your primary. And the reason is primary for some reason goes down. This computer, your backup now has been computing things exactly the same way. You've had it with you the whole time. I see a lot of people, I have a backup computer. It's in my room. I'll get it. No. But you want to get fairly close algorithms. Now, if you have two computers and one of them is more conservative than the other, because you're diving with them and you're going to look at both of them, the more conservative one should be your main computer. And the reason for that is if your main computer goes down and your more conservative one is your backup, you may find your more conservative one is in deco where your main computer was telling you things were fine. So you'd rather have your more liberal of your two computers to be your backup, but it's best to have two computers the same way. I had a guy I knew, one of the early adopter of tech diving, and he tells me he's diving a deep wreck and truck and a real extended dive. and they had hang bottles and shit like that, for the deco. And he said he came and said, well, I had two different computers. He said, my one computer told me I needed 6 hours of decompression. I said, geez. He said, yeah, the other computer told me I needed only 3 hours. I said, well, which one did you use? He said, I'm not staying down 6 extra hours. I don't know if that makes sense or not. A number of computers, you can factor in what's called a personal factor. It's basically just making the algorithms more conservative. So again, it's something you need to look into. All the dive manuals are available online. If you don't have yours, or if you're contemplating a new computer, do you want to make them more conservative or whatever? I mean, again, it's a pass-fail test. And depending on where you are, you don't want to be in the middle of the Seychelles and, I'm bent. So safety stops really factor in. At the same UHMS conference that I met Carl Huggins at, the guy who was the original director of the Catalina Hyperbaric Chamber, Andy Pilmus, was giving a demonstration. And Andy went from the Catalina Chamber to Brooks Air Force Base in Texas. And fighter pilot, high altitude fighter pilots have the same problems we have as divers come in, because the pressure's less up there, so they can get bent, but they get bent at altitude, not on the ground. And Andy had just this fascinating thing that there was an audible gasp in the room, where he had an X-ray of a guy's heart and lungs, and you could see these bubbles coursing through, and what you'd see all of a sudden would be this train of bubbles just shoot through the lungs and go, holy shit. And what they were finding was these were, and again, I may not get it exactly right, but these are what we're going to call asymptomatic bubbles. That you could be doing a dive with no decompression limits. You come up from that dive, everything is fine, you are not bent. You go down for your next dive, you stay within limits, and you come up and you get an unexpected bends hit. Well, what they found on a number of first dives, and they did this through this Doppler X-ray stuff, was that you come up and you're fine, but you would produce asymptomatic bubbles. And so these are bubbles that are just running through your bloodstream, but they're not causing a problem yet. Well, the science of bubble mechanics, which is what a lot of this is all based on, sort of says it's harder to create a bubble when there are no bubbles, but it's easier to create a bubble around already existing bubbles. So that if we had these asymptomatic bubbles running around when we think we don't, now you go down on this second dive, which should be a fine dive, but because these asymptomatic bubbles are there, new bubbles form, more bubbles than the model would predict, and that's how you get bent. What they found, and this is why we do safety stops, if you did a 3-minute safety stop at 10 feet, you got rid of 90% of the asymptomatic bubbles.
Wow.
And you basically eliminated the chance of an inadvertent hit on a second dive. Now notice I said 3 minutes at 10 feet. What's the recommendation generally from Nowie, Patty, and everybody else? What depth should your safety stop be at?
15 feet.
15. The reason it's 15, it's hard to hold 10 feet as a practical standpoint. You hold 10 feet, chances are you might rise up to 5. At 5, you may pop up. At 15 feet, if you go up to 10, you can probably get that down to 15. So that's why we changed to 3 minutes at 15 feet rather than 3 minutes at 10. But the same principle still applies. You are getting rid of tons of these asymptomatic bubbles that may or may not exist. And if they don't exist, hey, no problem. Also, people wonder, you're doing the safety stop, do you actually have to stop? Well, no. Just be at 15 feet. The bubbles don't know what the hell you're doing. So you could be in blue water, twiddling your thumb or you could be on a reef at 15 feet, looking at stuff, taking pictures, whatever's going on. The point is to be at that depth. It does not matter what you're doing. What I do personally now, as I think I mentioned earlier, I have decided I'd rather do 5 minutes. In fact, I know Mike Lever, who runs Nautilus, they sort of require a 5-minute safety stop. I do a 5-minute safety stop now pretty regularly, sometimes even a little longer than that. One of the things I like about my Pro Plus 4 is I can set the length of the safety stop. I think the choices are 3, 5, maybe 7 or 10. I won't swear to that, but you have a couple of options for time, and I have a couple of options for the depth where it kicks in. I can do 10, 15, or 20 feet. I happen to know that the computer actually goes into the safety stop 5 feet deeper than what you set it at. So I have mine set for 20 feet. So at 25 feet, I'm kicking into that 5-minute safety stop. I'll go through the entire 5 minutes and maybe wait another minute or two longer, and then go up. So for what it's worth, but generally, more safety stop is good. If you should ever think you're inadvertently have exceeded a limit, go to 15 feet, breathe your tank down to nothing, 10 minutes, 15 minutes, whatever you think it might be. And the other thing to remember too, especially on computers, so think of that picture I had up of the glass. You go beyond the no deco limit. And let's say it says, hey, you got to do a deco stop. You got to do 5 minutes at 15 feet. Fine, do your 5 minutes at 15 feet. But then add a safety stop beyond that. Because all that's done is take you right down to the edge of the top of that glass. Do another 5 minutes at 15 feet to give yourself a little bit more margin of error. The deco stop itself is not necessarily enough. And anyway, we talked about the idea of the backup computer. Better to err on the side of caution. Amy, you got a question? See, I told you I can see that.
I'm using the other hand. Yeah, and I'm not sure if this is what you were just about to go into, sorry, but you did mention earlier you set your computer to 28.
Mm-hmm.
You just leave it there? Like, I mean, even though you do the analyzer to obviously double check things, you just leave it at 28.
Yeah, here's what I do. And anyone who's been on a trip with me gets the lecture at the beginning of the trip. So most of the time, if we're on at a resort, or someone else is doing the mix for you, you're probably you think you're getting 32%. All well and good. So let's say you analyze the gas the first time, and let's say it's 32% right on the nose, and your computer set at 32%, no problem. Then you come do the second dive, and you analyze the gas, and it comes out at 31.2%. Well, you should change your computer to 31%, because 32% means you don't have it set exactly correct. And then you go for the third dive, and maybe it's 30.6%. What happens over the course of a day, especially if a place is filling a lot of tanks, that percentage number changes. And in theory, if you want to have your computer correct, and this is why we analyze the gas, you need to set your computer for whatever the whole number is that's just less than whatever you analyze at. So if you analyze something at 30.1%, your computer should be at 30. If you analyze at 31.8, you can be at 31, et cetera, et cetera. I have never seen anything get lower than about 29.8%. So I set my computer at 28% for a couple of reasons. One is I don't have to go change the computer setting every single time. And on the Pro Plus, all the Pro Plus lines, the original Pro Plus, the 2, the 3, and the 4, they have a really stupid thing in there where you can, as you're trying to set the nitrogen percentage, you can kick the computer into what they call gauge mode, which disables all the nitrogen readings and basically makes it a depth gauge and screws up your whole trip. But by doing 28%, I don't ever have to really change the setting. Excuse me, as well as I'm factoring in a 4% more margin. I'm just factoring a safety margin so that when my computer, thinking I'm diving 28% nitrox, says, hey, you're at your limit, I'm really not. That doesn't mean I'm going to violate the limit. It just means I build in a little bit of factor there. Now I'm going to do a safety stop, build in a little bit more. And again, as we get older, hopefully that lessens the chance, that we're getting bent or anything like that. So that's why I recommend, the 28%. I mean, 28% gives you a ton of time over 21%. And again, if you want to dive your computer on, if you dive in nitrox and you want to dive your computer on air, that's, having that set at 21% is about as a safety factor as you can factor in. So, and if you want to run it exactly at what the percentage is, okay, just remember, you're not leaving any headroom and you need to change it on every single dive. So that's the whole reasoning behind it. The one thing, by the way, I will tell you that you're screwing up is if you dive in nitrox, and I'm making an assumption that most of you are certified nitrox or have some understanding of it, or you're certified and have no understanding of it. I don't know. But that you are screwing up your MOD because by setting it at a lower percentage, you can dive in theory deeper. But the reality is the MOD at top of my head, MOD at 1.4% on 1.4 atmospheres on 32%. The MOD I think is 111 feet or something like that. I rarely go below 100 feet. And as Michelle or others can tell you who have been new to nitrox, we've been talking about it, just don't go below 100 feet, period. And you're fine with MODs. But so that is the one downside is setting it at 28. The computer will tell you you've got more, you could go a little deeper than you really can. Somehow I backed up there. There we go. Err on the side of caution. So that's sort of what I got for you, and hopefully, hang on, let me stop share here. Whoops. Get all your smiling faces back full on my screen. I mean, again, the basic thing I think is if you get that concept, again, of the glass filling up, don't let it overflow, goes back down, fills up, goes down, fills up, goes down. That's what's going on inside you. And hopefully that translates into, oh yeah, that sort of makes sense and that's how I can dive and blah, blah, blah. So if I haven't exploded your heads, what kind of questions we got, if any? Glenn? Unmute, Glenn.
Okay. The compartment, tissue compartments,
yeah.
Are they measurable? Are they like muscle groups and things like that?
Well, they're
density.
Yeah, I don't know how they necessarily come up with them. In other words, I could create a mathematical model. Now, let's just say I want to create something that's got 6 tissue compartments. And I'm going to say, there's a 2-minute tissue, there's a 5-minute tissue, there's a 10-minute tissue. And I don't know if in terms of the research, have you done anything where, I've actually done some stuff where I can say, yes, my forearm is a 10-minute tissue, but my shoulder is a 15-minute tissue and account for that. So again, mathematical models. Tom?
Yeah, Ken, so my question is, have you or has anyone else done any sort of an evaluation of the various computers available and how conservative or unconservative they are? Or do the different manufacturers talk about what tables or models they use?
So here's the thing with that. Here's my somewhat cynical joke answer. Just remember, the dive industry doesn't have a lot of money, so you are the R&D for most new products. That being said, Carl Huggins does, and you may have been out there when they've done it, Tom. Carl does a lot of computer testing in the chamber. And it's not so much necessarily testing the validity of, it's not human testing. It's not having someone dive in the chamber and Carl let them go till they get bent or anything like that. But he will test some computers against, like they put them on a board and they submerge them in water and take them down to 165 and see who says what, where, when, why. And and this one's giving you 20 minutes of decompression. This one's giving you 15. So I think more of it's a functional stuff. There is some stuff done. I'm not sure what the human testing is that's done before any given computer comes out, and I'm trying to think if there's any really new algorithms on the market. I don't think there are. I mean, the big ones you'll hear about would be Buhlman, Buhlman, one N or two, which is the Sunto ones are that way, real conservative. I mean, to my mind, it's almost like they're afraid to dive. I've been diving with people with Sunto. In fact, Tom, weren't you diving on a Sunto when we were down in Socorro, I think?
Yeah, I was.
Yeah. And I remember the first time I was diving with someone who had one, and we were diving in Baja at El Bajo, and we got hammerhead sharks around, and we're down about 95 feet or whatever, and I still got, 10 minutes left, and she's going, I got no time, I got to go up, because she was diving one of the Sunto ones. So I don't think anyone's ever really done, like I said, human testing. I can tell you that when we talk about flying after diving, that was done because I saw the research actually at this same UHMS meeting. But they did that with actual people diving in chambers and stuff like that. And actually, when you look at the numbers, the thing to remember on some of this stuff too is there's a lot of politics that goes on with this. The original DAN recommendations were 24 hours, wait 24 hours to fly after you do multiple days of diving, and take a day off in the middle. And the resorts were going nuts because they said, well, now someone's going to fly in on Saturday. They can dive Sunday, Monday. You want them to take Tuesday off. They can dive Wednesday, Thursday. Oh, they can't dive Friday because they're going to fly Saturday. And so stuff got changed. The official DAN recommendation is 18 hours. If you look at the actual research, really after about 14 hours, there were almost no incidences of people getting bent on the second dive if they flew. So there's that going on as well. But again, to go back to my original statement, the thing to remember is a lot of times you are the R&D for the dive industry. Who else got a question? Glenn? Or you're just waving at everybody?
No. I am, but as far as I know, Shearwater computers have been tested by the Canadian military recently. Okay. And that's why I bought one.
Yeah.
But because I had been diving Cobras and Suntos and Oceanics and all the other. Oceanics are completely opposite from the Suntos. They're quite liberal.
Mine's an Oceanic.
Yeah, but as far as I know, the Shearwaters are the latest or only ones to be tested on human subjects.
I hear a lot of people dive shear. How many people diving? Anybody diving? Other people diving Shearwaters here? Yeah. Like I said, the thing I don't like. I think they make a console mount, but I just don't like stuff on my wrist. I mean, the funny thing is, I love, like I said, I've dove Oceanics forever, but the thing I love is when people don't realize sometimes there aren't that many computer manufacturers, and they go, oh, I wouldn't dive the Oceanic. What a piece of crap. I like the Sherwood. I go, well, it's made by the same people, made by Pelagic. That's the way it goes. So, what other questions we got? Robin.
Are you familiar with the Cressy? Was it Giotto?
Yeah, I mean, I've heard of it. I haven't ever used it. I think, won't swear, I think it's a Buhlman model, but I won't swear to that.
It says it's moderately conservative, and the more repetitive diving or the more consecutive days, it gets more and more conservative in the algorithms.
Yeah. Have you ever compared it against another computer?
No, it never occurred to me.
I mean, that's the thing to try sometimes. Is, I mean, don't go out and buy one necessarily. I don't sell them anymore, so what do I care? But it's interesting to like to take two computers. I mean, I got this little computer that was called a BUD, and it stood for Backup Dive Computer, and it's just a little thing I keep clipped into my BC pocket. But it's the same algorithm as it's made by Oceanic as well. Same algorithm as my my big Oceanic. So yeah, I mean, do you feel it's not giving you enough time, or?
No, I'm actually a very conservative diver.
Yeah.
I just prefer it that way. So I'm fine with it. I was just curious because I'd much rather have a computer that's more conservative
Sure.
than conservative.
Sure. And remember too, the other way to make it a more conservative dive shallower. Dive shallower. Yeah, dive shallower, dive less. I mean, I got these two people who dove with me one time, and they will not go below 40 feet.
Oh wow!
And, yeah, and
I'm not that conservative, but
yeah,
you know,
gets caught on.
Did you hear him?
No, what did he say?
I said because their cane gets too heavy. When they
That's it. But yeah, they wouldn't go below 40 feet, and there was a current, and so okay, fine.
So Ken, I've been a little slow in getting a more current dive computer.
Yeah.
Last year, after I was on a cruise ship excursion boat in Curacao, they provided all the gear, and I had been diving rental gear in Hawaii for years before, so I didn't give it a second thought. And the depth gauge didn't work. It was stuck. I was at 45 feet the whole time, regardless of whether I was up or down. So since then, I at the end of the year, Garmin had a sale, and I bought a Descent G1, and it's been wonderful.
Yeah.
But it's small, to read, and we've been having this exchange a little bit about. I also have a Viper Suunto in my console that I use as sort of a backup, and the Suunto is more restrictive, especially on multiple dives.
Yeah.
We have, just real briefly, we have a scuba park here in Austin, Texas, and they had those floods, horrible floods that killed a lot of people last July, and all that water ended up in our lake after cascading through a number of other ones down the river. And so all of our dive sites that had, things at 40, 50 feet are now at 90, 100, 105 or more. So all of a sudden my profile's sort of changed a bit. So anyway, long, boring story short, I've been trying to figure out how to get my backup computer and my primary computer to sort of be in sync. And it took me a while to realize that I needed to at least have the same algorithm. So I dove this morning a brand new Shearwater computer along with my Garmin and along with the Suunto, and lo and behold, the Shearwater was the most conservative of the three.
Yeah,
at least out of the box. And I'm gonna have to make a couple little tweaks to get it a little more in line. But I really thought the Suunto was gonna hold me back.
Yeah. Well, you remember I mentioned Carl does testing in the chamber. I remember he told me one time he had a bunch of computers he was testing, and he threw in a Benzomatic just for the hell of it. And he said of all the computers, the Benzomatic was actually the most conservative. So scary stuff there. But yeah, it is a type of thing where you need to experiment a little bit. I mean, they have stuff now, Apple Watches now have a computer component that you can have the Apple Watch and buy the program for that. So, everybody's sort of getting into it. But again, the thing to understand too is, and you should be able to get this information in the dive manual back in the technical specs, how many compartments, what's the algorithm, stuff like that. Yeah. And again, you can probably do a thing where, I think even on mine, I I just run mine at the normal default stuff, but I'm pretty sure even in my Pro Plus 4, I think I've got 2 or 3 other, conservative factors I can dial in, which I don't because I'm comfortable with what it's given me and stuff like that. Other questions?
Hey, Ken.
Yeah, Dave.
Let us done.
Oh, Dave was raising his hand.
Yeah, close. Just a kind of an update on the Maldives trip. If you remember, I was having depth readings, questionable depth readings on my Suunto. Well, I sent them both in to Suunto. They ended up, and I don't remember which one was which, but one of them they replaced the pressure sensor.
Sure.
The other one, they replaced the entire unit.
So both defective.
Yes, to
some degree.
One more so than the other, I guess.
Yeah.
But interesting.
Yeah.
I'll be using them in 5 weeks again, so we'll see. But I thought that was interesting. I had a little over 200 dives on them. So.
Yeah, I mean, the problem with all that is, you're relying on everything. How do you really know that what you're getting is correct? You could dive with 2, let's say 2 air integrated computers hooked up to the same thing. I mean, we had one time a year ago when we were doing a lot of local dives, and one of my dive masters we're on the Sea Ray, and he's got an aluminum tank, and we do the first dive, obviously come with a tank full of first dive, and come back in the second dive, and he just pulls me aside. He says, can you make sure they understand, this is an aluminum tank, and they filled it to, no, I take it back, he has a steel tank. So they filled it to 3,000 PSI. And, steel tanks fill with 2250 with a plus sign that can fill with 25. But he said they overfill. I said, okay, sure. Easy mistake to make. So I say, Mike, I think you might have overfilled his tank. Mike goes, well, I didn't think I did, but okay, fine. So he makes a second dive, gets an air fill, about to do his third dive, because somebody says, God damn it. He says, can you please talk to me again? They filled the tank to 3,500. I said, oh, okay. I'll double check one. And I said, Mike, now he's got 3,500. Mike's going like, I don't think so, because we can, well, I'm sorry, I'll keep an eye on it. And so we go for the final 4th dive, and Steve comes up to me, and he is just livid. He says, God damn it, this thing's reading 4,000 PSI now. And I said, why don't we throw my gauge on your tank? And sure enough, tank's reading 2250. His pressure gauge was failing incrementally as we were going on the dive. So you just don't know. I mean, here's the comforting thing to take, that kind of gear failure, which is phenomenally rare, notwithstanding. You got to sort of really screw up to get bent. You generally don't get bent because you went 1 minute over. Now, don't take that as gospel. You can go violate your no decompression limits. But usually it's things that, I went 20 feet deeper than I planned. I stayed 10 minutes longer. I made a rapid ascent. Because don't forget, an ascent rate is a form of decompression. And so we're assuming, and the tables are based on the idea, that you are going up at 30 feet a minute, which is really slow. It's the other reason we like to have that safety stop. It brings your overall ascent rate down. There was a study done supposedly at the underwater park, Catalina, of people, and they just sat there and secretly timed their ascents. Now, when I got certified, the ascent rate was 60 feet a minute, okay? 1 foot a second. Yeah. Those who got certified since about 90 or so, it's 30 feet a minute. Okay, fine. Well, the reason that we want to slow down the ascent, we know you're not going to go 30 feet per minute, but with the secret timing, what do you think the average ascent rate was? Try 100 feet per minute.
Whoa!
That's how fast divers were going. And the reason that we want to have you do the safety stop is so you don't keep going up inadvertently. So
I was taught go as the rate of your small bubbles rising?
Hmm.
Is that not true anymore?
Go slower than your bubbles.
Well, okay, like
Lower than your bubbles.
Go
Cool.
slower than your bubbles are going up.
okay.
Okay.
Supposedly, your smallest bubbles rise at about 48 feet per minute. So
I'd say 47.5, Don, but
whatever. Yeah. Well, you talked about kind of going back to my two computers.
Yeah.
I first noticed it at a safety stop. I was with everyone else. I assumed we were all in the 15, 18
Right.
foot range, and my gauge was reading 25.
Right.
And so I started comparing the two on the next dive at depth, and they were reading the same. Don't know if that was accurate at
Yeah,
depth.
terrific. I got the same bad reading out of each computer.
Yeah. But when I came up again to the safety stop, one was reading 15 and the other one was
Right.
reading 21. So,
Well, and it's a type of thing too where I've tested pressure gauges, let's say, and they're accurate, let's say from 1500 to 3000, but they start to go off, when they're getting down low when you really need it the most. I mean, if I got 1700 psi in my tank and it tells me I have 1900, I don't really care. But if I have 300 psi in my tank and it tells me I have 1000, that's a problem. That kind of stuff. Dave Human, did you have a question? There we go. There's that hand
well,
up.
yeah, I was going to say a man with two pressure gauges or two depth gauges, a man with one pressure gauge or depth gauge always knows where he is. A man with two is never sure. So
I was just going to say that, only it was about watches.
See, that's why you have to have three.
Watches, anything.
Well,
yeah.
it's also like I got a new, to your point, Dave, I got a new oven thermometer, right? And so I'm cooking a pork chop the other night, and I hadn't tested the oven thermometer out. So I have my oven set at 410 degrees, and it goes beep, and I look at the oven thermometer, and it reads about 370. I don't know which one is wrong, but one of them's got to be wrong. So now I got to go buy another goddamn oven thermometer, but at least they're only $10. Is there more to your question there, Dave, or no?
Actually, two more things. One that could make you a lot of money, but
all right.
The first one is, why does 3 minutes at 15 feet make so much more difference than 3 minutes back on the boat?
Well, 3 minutes back on the boat, you are outgassing at a much higher rate. So at 15 feet, you are at about
half,
1.4,
almost more or less 1.5 atmospheres. It's just slowing you down enough, that you can get it. I mean, you could go, if you're not bent, you could go back to the boat. The idea of the 15 feet is that if you've inadvertently exceeded a no decompression limit, or if you got those asymptomatic bubbles running around, we can hopefully take care of that. Once you get back on the boat, or more to the point, once you hit the surface, game over. Because Carl will tell us even that if you, let's say you're right at an edge of a no decompression limit, and you inadvertently do an ascent all the way to the surface, he says once you hit the surface, those bubbles are starting to form. That you go back down to 15 feet at that point doesn't make any difference. And again, remember, in our chamber, we take you down to 165 initially, really crush the bubbles. Most chambers go down to 60. But the point is, you're not going to 15 feet to correct the problem. You're going very, 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 very deep. So it's a type of thing where the 3 minutes at 15 feet, it's like the old joke of a woman. I'm half Jewish, so I can do this joke with the accent. But this woman comes in and says, "Give him some chicken soup. Give him some chicken soup." The guy goes, "Mom, he's dead. It's not going to help. Wouldn't hurt." So it's the same thing. 3 minutes at 15 feet wouldn't hurt.
I'll just add something.
Wait,
to
Dave's
that,
got a second question. Go ahead, Dave.
Second thing, while I'm in the queue,
yeah.
We all come up from dives. Maybe not everybody, but I certainly have, and think, dang, I wonder, my neck hurts and my shoulder hurts.
Yep.
Is it just overexertion or am I halfway bent? For the tinkerers out there, couldn't you make something similar to a breathalyzer, not a benzolyzer, that you could breathe into or somehow measure the bubbles through a pulsometer or an
Sort of. Carl has some sort of a Doppler thing that he puts up to your carotid, and he can hear bubbles going through, and based on the sound, he can grade the how big the bubbles are and are they likely to cause problems. And he's done some kind of tests that way. So yeah, I don't think you do a breathalyzer because you're just going to be exhaling air. But yeah, if there was some way to do a pulse ox thing that could measure bubbles going through. Now the problem would be, what are you going to do when you discover bubbles? Okay, I'm going to the chamber. And a side note too, what I tell everybody, and again, those of you traveling before know this, I say, if something hurts, it needs to be something that doesn't normally hurt. If your shoulder is always stiff, don't tell me your shoulder is stiff. Something that's unusual for you. Otherwise, we send you to the chamber needlessly. So, yes, Robin.
2 things.
Okay.
One is, how often would you recommend replacing your battery in your computer?
Good question. And as a side note, what we do, we still do battery changes on computers at Reef Seekers, so you can bring it by or mail it to us. We always write the month and year that we put the battery in. It's hard to say. I don't know if there's a hard and fast rule. Every year or two. I mean, batteries are cheap, and change them more often than not. The last thing you want to do, in fact, it happened to Tom while we were on that Socorro trip. I remember one of the computers was going low battery, and we had to deal with that. So it's 2 things: change them fairly frequently, and carry a spare with you. Now, the flip side of that is, it's easy to do it wrong, and you don't really reseat the O-ring correct in the battery compartment. And I mean, the good news is, if you flood stuff, usually just flooding the battery compartment. But the point is, you're screwing up your dive. So we're always happy to do the change. But I mean, every couple of years can't hurt. I mean, I know on most computers nowadays have a battery indicator. And in theory, when you are flashing low battery, in theory, it should be good for a week's worth of diving. And remember too, once you are running the computer, I think I've got this right. If I have the computer going for a week and I do 1 dive a day, or I have the computer going for a week and I do 5 dives a day, that's not a further drain on the battery. In other words, doing dives doesn't make a larger drain on the battery. The computer's running. So, but yeah, you can, carry an extra battery with you if you can. But look at that thing. Usually 25% is about where they start giving you a warning.
So my second question, and it relates to something that was brought up. So when I was training, they said if you get out of the water and you get like a rash around your neck, or that like bubble popping sound as you move your neck, like those little the plastic things that people wrap presents in and stuff, you could jump back into the water up to your neck and try and cool your body down, and it might help.
My neck is cracking as I'm doing this, by the way. I'm not bent, though. No. Again, if we put you in a chamber, we're throwing you down to 60 feet. We're not throwing you down to neck depth.
Right.
2 things. One, skin bends, which a lot of times is not treated in a chamber, will manifest itself as a rash. A lot of times on your belly, apparently. I've seen it once or twice. I think sometimes on your arm. The neck thing sounds more like what's called the chokes, which again is bubbles there, but none of that is good. And I mean, the thing to remember about in-water decompression, which I've done one time, not me personally. I mean, I was on a boat. We had someone we thought was a problem. We threw him back in the water because we were 80 miles away from the nearest chamber and we wanted to figure out what to do. But again, in-water decompression, you're going to need to go down fairly deep, and you're going back into a life-threatening situation. You're alive on the boat. Bends normally does not kill you. Drowning will.
Yeah.
So that if you choose to go in the water to try to solve this, take somebody with you who can pull you out. Because again, you're going into an environment that can cause more problems. But I think the odds are that you would be causing, you could be causing more problems than solving them. That'd be my thought.
This rash thing you're talking about, I forgot the term you used.
Skin
Chokes.
bends.
Skin bends.
Oh, the bubbles are chokes, like I'm choking.
Oh.
The bubbles around the neck.
Yeah, the way it was I see. The way it was described to me, it was like all on the surface. So is that get back in the water, or there's nothing you can do?
Get back in the water is rarely going to be an answer.
Okay.
Unless I dropped something, I'll go back in the water to get it. But in terms of bends and stuff like that, it's like if someone embolizes, I'm not going to throw them back in the water.
Yeah, yeah.
Same idea.
Okay, thank you.
Yep.
There was somebody on the last trip I went to Raja who did get the skin bends on the
Skin
stomach.
bends? Yeah.
And then they called Dan, and then they were having a video meeting with the doctor or somebody
Yeah.
from Dan, and they were giving their whole dive profile, and they were breathing oxygen and
Yep.
all of that.
Did they finally take him to a chamber or no?
No, they ended up going to a hospital when we got back to land.
Yeah.
And then they had a second portion of their trip to Borneo, so they had to delay that a little bit.
Yeah. I was on a Kona Aggressor years ago, and we had a woman, not part of our group, got skin bends, and she was very overweight, not in good shape, and it wasn't that strenuous to dive, but we did a deepish dive, and she had the rash, on her belly, and so we called Dan. And they said the same thing. I think we had her on oxygen for a while. They said a lot of times this will resolve, on its own. This is first day of the trip. And so she then said she wanted to go back in 2 days later. So the first day trip, she gets bent on Sunday. She sits out Monday, Tuesday, wants to go back in Wednesday. And so they say, okay. And I think Dan had said it might be okay. So she goes back in, does one dive, comes back. Now it's worse. So we go, okay, we're going to have to go. And the guy who was the captain comes to me because it wasn't part of my group and says, look, we really got to go back up to Kona. Are you okay with that? I said, well, yeah, let's go. So we're running up to Kona. We got her on oxygen. She's conscious. She's not in pain, but we're going to put her in a chamber, right? And as we're running up to Kona, I just happened to be up on the upper deck. Kona Aggressor was a two-deck boat. I happened to be on the upper deck. I happened to glance down. And we're going 15 miles an hour or whatever.
The whale shark.
And I see a whale shark.
I remember.
And I go, whale shark! And I'm right by the captain's thing. And he looks up. I said, I know what you're thinking. He says, do I stop for the whale shark or do we continue? And I said, it's only skin bends. We can afford 5 minutes, don't you think? He goes, yeah. So we slowed down and circled back to the whale shark. So anyhow. But yeah, skin bends it definitely happens. It's not that serious, but it's serious enough it can get worse. I had someone else, we were on an Australia trip, again, not part of my group, thank goodness, and we dove the Yongala, and after the second or third dive, I know she was in a cabin across from me, and I wake up the next morning and I see she's on an O2 mask and the captain's sitting with her, and he says, yeah, we're going to let you know. And we did evacuate her off the boat. I mean, the other reason, just from a practical standpoint, not to get bent, other than you don't want to get bent, is Yongala is in Australia, and the Australian rule is if you get bent, you ain't flying for 6 weeks. So now you've got 6 weeks in Australia. Yeah, great vacation, but you got to, you got to pay for it somehow. Now, by the same token, I had someone one time, and I don't want you to think just because I dive a lot, it's not that I get people bent all the time, but we had a trip to Turks and Caicos, and one of the women got a mild bends hit. And so we took her off, put her to the chamber, and hooked up with her later on. They gave her a shirt, and it says, I got bent in Turks and Caicos, and all I got was this lousy T-shirt. So, we have one at the chamber, but it's a little bit more morbid one. The coroner has one that is a chalk outline of a body, and it says, "When your day ends, our day begins." So the chamber has one that's an outline of a diver falling that says, "When your dive ends, our dive begins." So we have that as well.
Well, the coroner has a gift shop. Let us not forget.
Well,
about
we closed the gift shop. Sheldon, I'll get to you in a second. We closed the gift shop, much to my dismay. But one of the fun things about the gift shop was they sold. I've got one that they gave me. I've got, you go to crime scenes and stuff, and people are in black windbreakers, and in bright yellow letters it says like FBI. Ours say LA Coroner. So I've got an official one. Well, they sold one in the gift shop, and apparently people were buying them and going to like crime scenes and walking in like they were official people, and they stopped selling those. They also sold a great beach towel that was an chalk outline of a dead body. But yeah, they stopped. Unfortunately, they closed the gift shop down. Sheldon, what do you got?
There's no chance.
Yeah, you need to unmute yourself, Sheldon. Nope, you're muted. Wait a minute, let me unmute you. I don't know if I can unmute you.
There it goes. Okay.
Yeah, you're good.
All right. So last week I watched a video of an experienced diver, and I'm looking at it right now. I brought it up again. I got bent 5 lessons for my recent decompression sickness incident. This is someone with a lot of experience and everything, and he insists that he did nothing wrong, absolutely nothing. I used to think that you must have done something wrong, even a little bit. Maybe you didn't drink enough water, maybe whatever it is, or too fast, whatever. And they were saying, like there might be a stigma that people look at you and say, yeah, he got bent. He must have done something wrong.
Yeah.
And the point was I did nothing wrong. I had everybody check my logs and everything. I'm diving for years. I have it right here. I'm looking at it right here. It's Divers Ready. It's the guy. I got bent 5 lessons for my recent decompression sickness. And it's kind of like, the point is that you can get it anyway. That no matter what, it doesn't matter. You can get it.
Right.
And that's what I understand. And I talked to Atlanta. I talk to every once in a while at Dan, and I spoke to her about this. And because I thought you did something wrong. And she says, no, that's the whole thing. It's that it can happen. It does happen. Even if you think you're doing everything right, you could be diving for 30 years. You're doing everything right, and it just can happen. And that was
you did.
Well, and I don't know if I would agree with it just can happen, because what I would say is we don't know why it happened.
There's a video.
But there was something. Send me a link if you can, or the video, or whatever. But
let me see if I know how to do that. I just copied, pasted. Let me see if I can send it to you.
Yeah. But one of the problems with the bends is.
Oh, here we go. Go ahead.
We guess on the symptoms. Oh, good. It's in the chat.
Yeah, I just sent it. Yeah. I sent it to you. I don't know if I sent it to everybody. I can't tell. Here, let me try everyone.
Yeah. It just says to me. Hold on.
Here we go.
Yeah, you can do it to everybody, I think. Yeah, there we go.
If you're in the chat.
The problem, you guys should be able to see it in the meeting chat, right? And just do what you can do is just do a copy and paste. Then you can look at it whenever you want, or just highlight it and copy. The problem with it is there are so many various factors that we don't know. And like I said, your limit today at 80 feet might be 40 minutes, and tomorrow it's 38 minutes, and there's no way to predict that. So the problem with the bends is when you come in, we can't necessarily, we don't have that little pulse ox that'll detect the bubbles in your fingers. So we're talking to you. You're scared to death. You don't know what's going on, and we have to take your word that what you're telling us is true. You tell me your shoulder hurts, I got to believe you. And then we treat you, and whatever was going on, we got rid of all the things that were causing the problem. So there's no way to prove once you were done that you were bent. It doesn't leave any real, I mean, even if you have residual problems, there's no way to detect that. So, I mean, a lot of it is just really, guesswork. So to go back to that guy, I mean, I would just say with a lot of the stuff, I like the term, I don't like the term undeserved hit. And you're right, there is a stigma about it, which I think should not be, because sometimes it does happen. But there was a reason you got bent. And we just don't know what it was.
Yeah, yeah. I mean, that's what kind of jarred me. Where, he insists, went over and over and over, had other people, and he just didn't do anything wrong.
Sure.
And I think so. So in other words, the whole point is, shit happens.
Yeah.
And that's just the way it is, and that's a lesson for me. Even though I didn't, thankfully, I just trying to be careful. I'm starting to dive more and go to different places and stuff. And I'm trying to be a little more respectful, not scared, because just to be respectful of things. And so that's why I talk to Dan. The person I speak to every so often, she's like the head medic, one of the head medics. I don't know if you know her, Atlanta, but that's what she said.
Yeah,
it happens more often.
I mean, it's like I've been asked numerous times. Have you ever been bent? Have I ever been bent? And I say my most honest answer is I've never been treated in a chamber. Wow. I believe you dive often enough, you've probably been bent and didn't know it or didn't do anything about it. All I can tell you is there was one time I was diving and the tip of this thumb was numb. Not fully numb, but maybe 20-30% numb, enough that I noticed it. And I didn't think I was bent. I didn't go get it treated. I didn't go on oxygen, blah, blah, blah. To this day, this finger is probably 3% numb. I don't know what, but I can still feel, was that the bends? I don't know. Did I get lucky? I don't know. Am I just getting old? That I'm pretty sure that's happening.
Okay, you're still alive.
Yeah, true. True. I'm still hanging in there.
Yeah.
At the ripe old age of 22. Maybe not quite 22.
Right. I don't know if you're getting old. You don't know if you just don't know.
Yeah. Well, and that's the other problem with the bends. The bends, I mean, here's the bottom line. I'm in 6 months, I hit 75. And the bends mimics all the problems of old age.
Maybe ate something bad the night before.
Yeah, that too. I mean, you just don't know. And that's again why I say, if you think you're bent, it should be pain that is new and unusual for you, not just my shoulder hurts. Because I guarantee if we take you to a chamber, it doesn't cure old age. Pretty sure about that.
I think Michael Jackson might disagree with you.
The day Michael Jackson died, you've all seen that picture of him in his own little recompression chamber. And the guys I work with at the coroner's office, they had this wonderfully elaborate way they smuggled him out. But I was sort of hoping they were going to have me come in and consult because of him being in the hyperbaric chamber, but that didn't happen. So, any other questions?
No.
All right. I'm gonna when the AI thing prints, it just goes to me. I think I will just send all of you that. I'll see how accurate it is. I mean, we've been going for, oh my goodness, 2 hours and 15 minutes now, so it'll probably be a little longer than a page. If anybody wants a copy of the PowerPoint that we did tonight, I can send that to you. I think I can do that in an email. Just shoot me a note and I'll shoot it back to you. I think it's about 6 or 8 megabytes or something like that. And if
And
you
was
have
that-
any questions or anything,
Yeah,
you
Ken,
know-
real quick, was that you at Eco Dive doing a lecture a couple months ago? There was someone from the what do you call it? Not the morgue, whatever you call it,
not the morgue. No,
whatever
I speak at Eco Dive every now and then. I think the last time I was there
I saw you there.
was I don't know, for chamber
Months ago,
thing.
maybe.
So
Yeah, I saw you there.
yeah, and I saw you. It's the easiest thing to say.
Thank you so much for a great class, Ken.
You're welcome.
Thank you.
And again, hopefully you picked up a couple things. And if you got any questions, shoot me a note or give me a call and let me know.
Thank you so much. And the visuals in your PowerPoint were very helpful, as well
Good.
as like all the information you provided. And I always appreciate your humor.
Good. Thank God. Thank God. So because the humors ain't going anywhere. So thank goodness some of the jokes land. All right, everybody. I'm going to kick you all out. It's nothing personal. Just the way we got to end the meeting. Have a lovely holiday season, whatever you celebrate, and hopefully we'll do some diving with you in the new year. Thanks a lot, guys.
Here, happy holidays, everybody.
Night, everyone.